So the story goes back to really the 1980s and the 1990s, specifically the 1990s. So I'm interested in looking at a decade where biotechnology and medicine were really coming up with some important inventions stroke discoveries in molecular genetics. It was a time when genes for heart disease, hypertension, arthritis, various types of cancer had been patented by the USPTO. And basically kind of the political climate for the patenting of genes. First is the Stephenson-Meidler Technology Innovation Act. You probably know this infinitely better than I do. Passed in 1980. It enables scientists at federal agencies such as the NIH to enter into licensing agreements with commercial entities that promote technologies that were developed by governmental scientists. And then more importantly, I would argue the Bayh-Dole Act of 1980, which also known as the University and Small Businesses Patent Act, which cedes to universities and small businesses IP rights. During the 1990s, certainly biotechnology has been an emphasis of all political parties, Democrat and Republican alike. During the 1990s, the Clinton administration's rather strong support of biotechnology was seen as what he calls the Biotech Directive of January of 2001, which clearly recognizes the importance of gene patenting to the US economy. William Hazeltine, and we'll talk about him in depth, a rather interesting individual, was president of Human Genome Sciences, was a professor of biology who did pioneering research on HIV/AIDS at Harvard back in the 1980s, was delighted with the Clinton directive, and he argued, and I quote, I'm getting old so I have to wear my glasses for quotes, established clearly and in the most dramatic fashion the patentability of human genes. It is indeed the Magna Carta of biotechnology, unquote. And the critic and the bioethicist Sheldon Krimsky of Tufts also agreed, but thought it was a disappointment. Quote, if anything, the document reinforces the move toward economic colonization of the human genome and other biochemical substances found throughout nature, unquote. And indeed, that 2001 directive of Bill Clinton mirrored the European Biotech Directive, many of you will know better than I, that became effect in July of 2000. It was highly controversial as not all member states were on side. There were huge debates. France was the last to sign off in 2004. The Dutch were rather upset about patenting products of the human body. So when we talk about the EU directive, it's not as unified as one might imagine. The molecular biological context of this, of course, is the Human Genome Project, in which back in the night, it started in 1990, it went through 2003, it stopped 2 years early. It was originally intended to be a public venture. The Americans spent $3 billion to sequence 3 billion base pairs. It was $1 base pair, so it was cheap back then. I'm convinced that's how they came up with the number. Also, Europe helped out. There were major sequencing centers at Cambridge, the Sanger Sequence Center, Japan, Germany, and also there were private companies, rather famously Tigger, and Celera, and we'll talk about those in a bit. And so the public-private debates really began to sound rather loudly, particularly over the notion of patenting genes. So what's at stake? Well, a whole lot. Certainly the BRCA1 and BRCA2 decision was about the fear of monopoly. The fact that when you patent genes, you can in principle block downstream therapeutics and research. That's a problem. And unlike, say, chemical intellectual property, you can't really invent around a gene. And the inability to invent around a gene is the major problem with this, with the application of chemical intellectual property law. I'll go into that in just a bit. There's fears, and there have been a number of studies by colleagues of mine at Stanford. If you're interested, I'm running a conference at Caltech. You're all invited. It's going to be in May, so it'll be great weather, on precisely intellectual property and molecular genetics. We have people from the ACLU and some from major IP lawyers from major corporations. So if they don't kill each other, it'll be a great conference. There has been, and Mildred Cho of Stanford has argued this increase in secrecy, that if you're working on a research if you're working on a gene that you wish to patent, the probability that you will not discuss it until it's actually patented is much higher. And so because the average time for a patent on genes is now about 3 years, back in the 1990s it was 5 years, you're holding up a large amount of information in molecular genetics. There's also public health concerns, and that's clearly with breast cancer, BRCA1 and BRCA2 genes. And of course the argument is, if we pull the plug on patents, will that thwart innovation and invention? Because clearly these companies want capital, right? And intellectual property is the capital, the currency that they have. Certainly true with sequencing companies of the 1990s. Many of these sequencing companies died. The ones that survived were the ones that got bought out by pharmaceutical companies, such as Human Genome Sciences. They had a relationship with one. Insight then went more towards the pharmaceutical end. Millennium up in Cambridge, Mass. is another example. So that's kind of the Wagnerian, I love opera, introduction. Now the story.